All right, so now we're going to continue our S11C handout, and so we can look at this and we have our amplitude is 5, our B value is 30, and our principal axis is 20. So the very first thing I do when I see something like this is I'm going to draw my principal axis at 20 right now. So here's 20, and I've got my principal axis right there. Okay, at 20. Amplitude is 5, and this is a cosine wave, so we start at the max. So we're going to start here, and our B value is 30. So to find the period, it's equal to 360 divided by B. So 360 divided by B is going to give me 12. So between 0 to 12, it's going to do a full period. So, and the amplitude is 5. So since the amplitude is 5, it's going to start at 5, end at 5, and right there it's going to be go 5 below the principal axis. So halfway between the maximum and minimum is where it crosses the principal axis. Halfway between here and here is where it crosses the principal axis. Do not just draw a straight V. No. So you're going to draw a curve that looks like this. Okay? And then you're going to repeat. Okay, draw the curve that looks like this. All right? So there's our sketch from 0 to 24. And one period goes between 0 to 12. Okay, find the average temperature during the month of May. Okay, so May is T stands for the month, starting after January. So May is when T equals 5. So January, February, March, April, May. So May is when T equals 5. So we're just going to plug 5 into my equation. So D of 5 equals 5 cosine 30 times 5 plus 20. And we type that into the calculator, and we get approximately 15.7 degrees Celsius. Make sure you close this parentheses. That's the biggest mistake I'm finding with this. Okay, question C. Find the minimum average daily temperature and the month at which it occurs. Okay, so the minimum temperature happens here and here. Okay, so so this happens at 6. So this would be when T is equal to 6. That would be in June, and yeah, so that would be at 0, and this is at 12. So we're back at January, right? January. Now some of you are thinking, why is the lowest temperature in June? So you might notice that and wonder. Now the thing to note is this textbook is from Australia, so we must be in the southern hemisphere. Because why on earth would the lowest temperature of the year be in June? And that's because this book comes from Australia. And it must be in the southern hemisphere. Okay. The temperature inside Vanessa's house after midday, let's call that noon, is given with this function. Okay, so we've got our amplitude. Our amplitude is 6. we know the principal axis is equal to 26, and we know that B equals 15. So the period has to be 360 divided by B. So the period has to be 24. So once again, we're going to start off with the principal axis at 26. So here's 25. So it's pretty close to right about there. 26. Okay. The amplitude is 6. So I'm going to go 6 above and 6 below. Okay. Since it's a sine wave, we start at the principal axis and end at the principal axis. And the period is 24. So that means from 0 all the way to 24. From 0 to 24, it does the full cycle. So if we start at 0, we're going to be halfway at 12, and we end up here at 24. My maximum happens halfway between 0 to 12. My minimum happens halfway between 12 to 18. And so now I can draw my wave. Okay. So 0 to 24 is my period, right? Amplitude is 6, so it goes 6 above. So this value here is at 32, because 6 above 26 is 32. The lowest value, 26 minus 6, is going to be here at 20. Okay, so find the temperature inside Vanessa's house at midnight. So here is midnight. So the temperature at midnight is equal to 26 degrees. Okay, at 2 p.m. 2 p.m. is like right around here, right? 2 p.m. So what could we do? We just plug in 2 in the equation in place of t. So for BII, we have t equals 6 sine 15 times 2 plus 26. And we get 6 sine 15 times 2, close the parentheses, plus 26, and we get 29. Okay. Lastly, find the maximum temperature inside Vanessa's house and the time at which it occurs. So the maximum temperature is 32 degrees Celsius. And when does it occur? It occurs at 6 p.m. Okay, next. You may want to hit pause and rewind to see this one again. Okay. The depth of the water at the harbor after midnight is 4 cosine 30t plus 6. Okay, so my amplitude is 4. My principal axis equals 6. And my B value is 30. Okay, first thing, let's draw our principal axis at 6. Okay. Since B is 30, we can find the period is 360 divided by B, or 360 divided by 30, and we're going to get 12. So from 0 to 12, it's going to do a full period. This is cosine, so it's going to start at the max, and it's going to start at the max and end at the max, kind of like this shape here. Okay, my amplitude is 4. So since the amplitude is 4, it's going to go 4 higher than 6. So if I add 4, I'm going to go up to 10, and the period is 12. So here it's going to, after from 0 to 12, it's going to be end up back at the max. The minimum will happen halfway between 0 to 12. So, and the amplitude is 4, so I'm going to go 4 below 6. So the lowest point it's going to go to is 2, and the highest point it's going to go to is 10. Okay, so halfway between 0 to 6, I'm going to hit the principal axis. Halfway between 6 and 12, I'm going to hit the principal axis. And now I can draw my cosine wave. Okay? And then it repeats itself. And do not draw a V. You're going to get points marked down. Okay. It's a curve. All right. All right. Find the highest and lowest depths of the water and the times at which they occur. Okay. So for question B, the highest the water goes is 10 meters, and it happens at midnight, and it happens at noon. Okay, because at midnight and at noon we're at the highest. The lowest is 2 meters high, and then it happens at 6 a.m. and it also happens at 18. What is 18? 18 is 6 afternoon, so 6 a.m. and 6 p.m. Okay, that's 18 o'clock. So 6 p.m. is at 18 o'clock. Okay. A boat requires the water to be 5 meters in order to sail through. Will the boat be able to enter the harbor at 8 p.m.? Okay, well here's 6 p.m., right? 8 p.m. is somewhere over here, right? And the question is the water going to be deep enough for the boat to go through? So the picture is not accurate enough to really help me figure that out. So I'm going to have to put this into the calculator. So let's type in our equation, hit y equals, and I'm going to say 4 cosine 30x, close parentheses, plus 6, and the boat has to be 8 meters. You know, I just thought of an easier way to do this. Let's plug in 8 in for t. Okay, so 4 cosine 30 times 8, close parentheses, plus 6. And then we get 4. Wait, it shouldn't be 8. 8 p.m. is... At 8 p.m., this should be 20 hours. I bet we'll get the same thing though, because 8 p.m. 6 p.m. and 6 a.m. the same value, so 8 p.m. and 8 a.m. should be the same value. So let's see if that's true. Second. Okay, so we're going to change this 8 to 20. I bet we get 4. Dun, da, da, da. We do. So this is equal to 4 meters. Okay, so at 8 p.m. we're at 4 meters, and the boat requires 5 meters deep in order to sail. And at 8 p.m. we're at 4 meters. So the answer is no. The water is not deep enough at 8 p.m. Okay, you might want to hit pause to think about this some more. Okay, question 5. Here we've got this graph. So looking at this, we know we want to find the equation. Okay, so we know the period equals 360 divided by b, and our period is 12. So I can say 12 equals 360 divided by b, and I could switch this equation around, and I get b equals 360 divided by 12, and so b equals 30. Okay, and question A says show that b is equal to 30. Okay, question B, find the values of a and d. So we've got a principal axis through there, and we said that the principal axis is the maximum plus the minimum is equal to the maximum plus the minimum, so 12 plus 3 divided by 2. So 12 plus 3 is going to give me 15. 15 divided by 2 is 7.5. Okay. And then to find the amplitude is the distance between here and here, right? So the amplitude we know is the max minus the min divided by 2. So that's equal to 12 minus 3 divided by 2. So 12 minus 3 is 9, and 9 divided by 2 is 4.5. So now I can write my equation. Y equals A, which is 4.5, cosine B, which is 30, x plus principal axis 7.5. You might want to hit pause or replay to think about that. Question C. Find the average UV index for Santiago during May and give your answer to the nearest whole number. So for question C, May is when t equals 5. So I'm going to plug in 5 in place of x. So we're going to get 4.5 cosine 30 times 5 plus 7.5. And then I end up with 3.60288. And it says round to the nearest whole number, so y equals 4. And that's our UV index. Okay. Next page, last page. Okay, state the value of D. So D is our principal axis. So D equals 120. Find that right away. Okay. How often does a cycle repeat itself? So we start here and it repeats, it stops right here. So so what is this number here? Well, we can do another cycle, and it's hard to tell where it stops, right? But we do know that B equals 15. So if B equals 15, then we can say that the period is equal to 360 divided by B. And so we could say that that's equal to 360 divided by 15, which is equal to 24 days, since T is in terms of days. Okay, so how often does the cycle repeat itself? Every 24 days. Okay, question C. Given that petrol price at day 10 is 129 cents per liter, find the value of A. So for question C, I'm going to plug in 10, and so here's the equation. Y equals A sine 15 at day 10, so I'm going to put in 10 there, plus, we know D is 120, and they said that this is equal to, C is equal to 129. Okay, so to solve this, let's just get rid of this to make it easier to see it. Okay, I could subtract 120 on both sides. I get A sine 150 equals 9, because I subtracted 120 on both sides. Sine of 150, and I get 0.5. So A times 0.5 equals 9. And so divide by 0.5, and A equals 18. Okay. Question D. Find the minimum price of petroleum at the service station. So the minimum is when we do our principal axis minus the amplitude, right? And so our principal axis is 120. Our amplitude is 18. So I subtract the 2, and I get 102 cents per liter. Okay, E. Find the price of the petrol on day 17. So I'm going to plug in 17 in for T. So I've got C equals 18 sine 15 times 17 plus 120. So I've rewritten my equation, except I've plugged in 17 in place of T, and plug it into our calculator, and I get 102.6 cents per liter. Okay. All right. Question 9. You've got a paint spot X that lies on the edge of the wheel. The wheel has radius of 3 meters. it rotates clockwise at a constant rate and can be seen every 4 seconds. Okay, so um, so we know the period equals 4, and the period is 360 divided by b. So I can rearrange this and get b is equal to 360 divided by 4, and so now I know that b equals 90. Okay, so we're trying to find the model. Okay, so the wheel radius is 3, so we know that A equals 3. And D, how high is this? So we know that from here to here is 3, and we know that this is 1. So H here has to be 4, because we know that 3 plus 1 gives me 4. So, and this height here, this height of H gives us our principal axis. So our principal axis is equal to 4. Okay, and our amplitude is 3. And so let's write our equation now. H of t equals 3 sine 90 x plus 4. So this 4 comes from our principal axis, the height of the water wheel. 3 is the radius of the water wheel, and our period comes from how fast it's moving. Okay, so now we need to draw our wheel. It rotates clockwise. So at t equals 0, we're right here at x. And if it's rotating clockwise, it rotates clockwise at a constant rate every 4 seconds. H is the distance to the bottom of the boat. Okay, find the sine model. Okay, so if it's a sine model, we're going to start here at 4, and it's rotating clockwise, so it's going up. And our x-axis here is not labeled, so I'm going to call that 0 for 8. Okay, so from 0 to 4, it's going to do. So first of all, let's draw our principal axis. Okay, and every 4 seconds, it does a full cycle. So it'll be back here at 4 seconds. So why did I put a 0 there? 2. Okay. So so if it's going clockwise, halfway between 0 to 2, I'm going to be at 3 meters. So 3 above 4 is going to give me 7. And halfway between 2 and 4, I'm going to be lower 3. So 4 minus 3, I'm going to be at 1. Okay, so now I can draw my curve. Right. So this amplitude, this distance here is 3 units. And this distance from there to there is 3 units. And we know our principal axis is at 4. And we know that from here to here, it does it in 4 seconds. And then the pattern repeats itself. Okay. Question B, is x above or below after 6.5 seconds? So 6.5 is over here, right? So I would say it's below. And what you could do is you can plug in 6.5 in for x, and you end up with 1.878 meters. And like I said, that's below the water level. Alrighty, that's it.